Okay. So last few lecture we go with some decomposition technique of high performance computing. We observe the number of techniques related with the decomposition, that is the recursive, data decomposition, then speculative decompositions, hybrid decompositions, and some of the example related with the decomposition. So next parameter is related with the characteristic of task and interaction. So that parameter is also considerable, that how we creating a task, and which parameter will be considered to when we making the task, because this task need to be a go with the performing of number of parameters, right? So regarding this parameter we go with uh, some characteristic of task and its interactions, right? So the various decomposition techniques described in the previous section, we know that decomposition technique we learned in last sections, as allows to identify the concurrency that will be available in a problem and decompose into a task that can be executed parallelly. So whatever we think learn in the last two lectures and two parameters or number of lectures, so what are the decombination methods will be available during that parameter, that concept will be consider. So regarding this parameter, just a second. So this technique will be help to that how we create the task, and about the number of decomposition parameter, right? So that parameter we have to learn here. That concept will be how to we learn parameter related with that concept, right? Uh, just a second. Just a second. So, actually, the characteristic of task is divided into two parameters. One is a static task, and second is a dynamic task. So, whenever you go with uh, creating the task, how the task will be generated. The task that can be constitute a parallel algorithm may be generated either a static or dynamic. So, there are two way of to generating a task. One is a static, and second is a dynamic. So, what is the static task generation? Refer to the scenario where all the tasks are known. I mean, before you going to a develop or going to any algorithm execution, you know the all the tasks. Before the algorithm start execution, the data decomposition usually lead to be a static task generation. Example is a matrix multiplication. So whenever you go with the matrix multiplication, you know the number of parameters, how they can be a generator resultant matrix. We depend upon their parameter. That things we learn in a data decomposition method, right? So refer to the scenario where all the tasks are known before the algorithm start execution. The data decomposition usually lead to be a static task generation, and dynamic task generation. In such a decomposition, the actual task dependency graphs are not explicitly available priorly. Means we does not know how the which type of transaction and which will be executed in next when. So that type will be a go with a dynamic. Although the higher level rules or the guidelines governing that task generation are known as a part of the algorithm. So at the time of situation, which type of task will be executed, that time will be decided. It not be a pre-decide that parameter, right? Some of the condition that will be a go in a parameter will be a go. Also, we consider with a dynamic task allocation. So recursive decomposition can be lead to be a dynamic task generation. Or quick sort, we say that in sorting we know that which set and which parameter will be come next. We does not identify before we go with the sorting. deciding the pilot parameter, other parameter. That concept will be a comes in a dynamic task generation. So basically, there are two. One is related with a static, and second is a dynamic task generator. Static In a static task generation, we know that all the tasks before we go to execution of your algorithm. But in dynamic task, we does not know about which parameter will be a go to be a executed during the number of parameters. So that will be a consider related with a dynamic task. So in task characteristic, also there are number of parameters we have to consider to learn about that concept that were related with the task size, right? So what is the task size related with that one? So the size of task is a relative amount of time required to complete. So what is the task size? The size of task is a relative amount of time, relative amount of time required to complete. So whatever the time required to complete one of the task, that will be considered as the size of that task. That is whether or not they are require roughly the same amount of time. It may be a possible if the amount of time required by the task varies significantly, then they are said to be a non-uniform. If the size of the two different tasks and the number of tasks will be a differ, so we say that they are non-uniform because the execution time period we require is a different. So time period of execution is a different, meaning of that the size of that task will be a different. So they are non-uniform. So the task is nothing but the amount of time required to complete that task, that will be a size of that task. Next is a knowledge of task size, right? So what parameter will be considered in a knowledge of size? The third characteristic that we influence the choice of mapping scheme is nothing but the knowledge of the task size. If the size of all the tasks is known, then this inform can be often used in a mapping of tasks to be a process. Is indirectly we say that if you know the all the tasks, the time period required for that task, so we easily find out the size of that task or execution time period of that one, right? So if we, which can be a know the exact time of that one and processing of time of that one parameter. So we say that it will be a knowledge of the task. So fourth characteristic of the related with the technique is the size of data associated with the task. So, what is the size of the data associated with the task related with the respective task? So, it may be will be a different because data different tasks use the different type of data. So, is nothing but the another important characteristic of a task is the size of data associated with it. The reason this is important consideration for the mapping is that data associated with a task must be available to be a process performing that task, and size and the location of this data may be a determine the process that can be a performed at the task without increasing exclusive data moment overheads. Different type of data associated with the task may have a different size. So same thing will be considered that if different tasks will be a different data, so it may be a possible the size of that data task will be a different because we know that we does not identify which type of data will be a go with which type of that one. So size will be a varying. Data is varying. The size will be a varying. Base example, suppose we taking that C is equal to A into B into C. We taking three parameter, right? Suppose we say that F is equal to uh, C into F into suppose Z divided by A. So what will be the data will be utilized by that second task will be more because it require more data. It requires C. So C is A into B into C. So first C will be a perform. The C data will be collected. then whatever the f and z we use, then we divided by a. So different data will be required by different tasks, so size of that will be a different. So that will be a characteristic of the related with your task and interaction. Is first static, so we know the all the tasks whatever before you execute it. Dynamic, we does not know the uh, what task will be executed at that time. So it is a on time relation. So size depend upon that one. Then task size we learn. Then knowledge of task size and the size of data associated with a large task. So that parameter we go with a learn. So considering that parameter, another is a characteristic of inter-task interaction. It is related with inter-task, and this is related with a interaction, right? So inter-task. So in inter-task, we go with the static, um, static various dynamic or varies dynamic. One way of classifying the type of interaction that take place among the concurrent tasks is to be a consider where or not this has to be a static or dynamic platform, right? So static versus dynamic. When we consider the static versus dynamic parameter, one of the um, classifying the type of interaction that take place among the concurrent tasks is to be a consider whenever whenever or not this has to be a static or dynamic. So we does not that, because when we go with a static and a dynamic, so allocation of data and size of that will be a different. So we does not identify the that things related with the that parameter. Second is a related with the regular versus in irregular. So in another way of classification of interaction is based upon their spital structure, right? And interaction pattern is consists to be a regular if it is has some structure that can be exploited for the efficient independent. On other hand, an interaction pattern is called as a irregular if no such a regular pattern will be executed. So second way, first way is related with the size, right? Or we know the task. First is related with if we know the task, we execute the parameter. If does not we know, we does not find out the size. Second is related with if the tasks are regular, continuously same task will be executed, or it may be a irregular. Some of the different tasks will be different. So that parameter also considered with the inter-task interaction, right? So that parameter will be considered with the static versus dynamic and regular versus irregular parameter of the characteristic or related with the inter-task interaction. So these are the parameter related with the characteristic of task and interaction and the characteristic of inter-task interaction. So these two parameters will be mostly considered for the characteristic point of view. So next point, whatever we learn about that parameter, the mapping technique for the load balancing, right? So we have to go with some of the technique with the mapping technique for the load balancing. So there are different technique of load balancing. Either it is a dynamic or mapping or the static mapping. So that parameter will be considered related with the parameter. In static mapping, the static mapping technique is distributed the task among the process prior to execute of the algorithm. So in static, we know the all the tasks. So allocation of task will be done previously. So we can process the prior basis execution. But in dynamic mapping technique, the distribute the work among the process during the execution of algorithm. At the time of execution, we can release and distribute the task because we does not know which task will be executed at a which time. Depend upon the condition, the task will be doing. But in static, it is a predefined task, so we can go previously allocation of the task. The choice of good mapping is the case depend upon the several factors. In static, there are number of conditions for to select the good mapping parameter. So first is the knowledge of task size. We know the knowledge of task size. Second is the size of data associated with the task. Then characteristic of inter-task interaction. Then parallel programming concept, right? That parameter will be considered for the choice of good mapping. Uh, in this uh, in this case, depend upon the several factors. In a dynamic, if the tasks are generated dynamically, then they must be mapped dynamically only, because we does not know which task will be executed, so they are allocated dynamically. But in static, it is a predefined character, a parameter, to how the task will be allocated. If the amount of data associated with the task is large related to the computational, then in a dynamic mapping may entail the moving this data in a among the parts. So if the large number of data will be present in a dynamic allocation, we divide into a sub part and allocated depend upon that parameter. In a scheme for the static mapping, there are number of schemes for the static mapping. First is a mapping based on the data partition. It consists the array distribution scheme, block distribution scheme, cyclic and block cyclic distribution, then randomized block distribution. Then in a scheme for the dynamic mapping are controlized scheme, master process, slave process, or a distributed scheme. So there are these are the scheme allocated with a stacking and mapping. So in mapping based on the task portioning and related with the number of parameter. So these are the actual difference between the mapping technique. One is a static and second is a dynamic mapping. So static mapping, all tasks will be allocated beforely, uh, because we know the all the tasks, but in dynamic we does not know the task, so we can allocate at the time of execution. There is predefined structure to allocate the task in a static, because we know the all the tasks, so it follow the sequence. It consists of knowledge of task size, size of data association, characteristic of inter-task interaction, parallel programming concept. But in dynamic task, we does not predict that one. Depend upon the condition, we can allow the task and allocate the task. If the data is available in a large form, so we can divide into a sub data, and then we allocate the subtask also. Also it uses some different scheme. In static we go with a block distribution, cyclic block cyclic distribution, randomized block distribution. But in a schema dynamic stuff, we go with a master process or slave process. So these are the scheme related with a mapping parameter related with a uh, concept of the static and dynamic mapping. So totally concerned with that one. We go with most of the second unit. We go with a decomposition parameter that will be a consider all the methods of decomposition. We have to explain with the example. That parameter we go with. Then some characteristic related with a uh, task that will be we go with that one, that is a static and dynamic task generation. Then some characteristic related with that one, interaction related with, then some mapping technique, static mapping, dynamic mapping, that concept we are learned. So you go with all that one concept and it will be a mostly consult parameter with related exam point of view.